Okay, so we've started our discussion of matter, but I'm going to make a couple videos for you so you can follow along and maybe rewatch while you're at home if you need to. So, matter is anything that has mass and takes up space, and we've talked a little bit about this. It's anything you can carry or you can hold. So, if you see it, if you can grab it, if you can touch it, if you can, um, take it with you somewhere, it's matter, or if it has mass. So, um, air is one that people forget about, right? You can't see it, you can't necessarily touch it, but you can bottle air, you can put it into a container. It does have mass. So even though you can't see it, air is not considered, or excuse me, air is considered matter. Flip side of that, light and sound contain no mass. You can't really touch them. You can see them or you can hear them, but they're not considered matter because they don't have mass. They don't take up space. Okay. When we talk about matter, the main thing that makes up matter are, first of all, atoms, and we'll do a big discussion of atoms with our next unit. But atoms make up elements. Elements are all these things on the periodic table, and they are a pure substance that cannot be broken down any farther. So things like oxygen and carbon and nitrogen and phosphorus and calcium and mendelevium and iron, and we could go on and on. All those things are atoms, elements made of atoms that are on the periodic table. They're a simplest part that can exist in a free state, so we can find all these things by themselves. And when they're on the periodic table, they are represented by a one or two letter symbol. So, for example, carbon is a capital C, or iron is capital F, lowercase e, one or two letter symbol. There are more than 110, and actually, there's 118 right now. Maybe more discovered someday. Some of these things have actually been discovered in a lab, so they're man-made. And again, this is another thing we've discussed in class, but elements make up living things and non-living things. But really, living things comes down to about 30 elements that are really important to us. So I have a ton of elements inside my body, but really the most important ones for us and for living things are these four down here at the bottom: oxygen, hydrogen, nitrogen, and carbon. About 90% of the mass of all living things is made of those four elements. Although we still have other things in our body, we have calcium, we have phosphorus, um, we have iron, we have all kinds of elements in our body, but really most of our mass, the largest portion of us, comes from those four elements. This is a picture of the periodic table. We will go through this pretty detailed in our next unit. Now, what we can do is we can take elements and we can create another pure substance called a compound. A compound is when I take two or more elements and I combine them together. And when they're linked together chemically, they're held together by bonds. They create a compound. Compounds are called pure because they're chemically combined, and they will assume different properties than the things that make them up. So, great example, an easy example is table salt. Table salt is NaCl. Na is sodium. Cl is chlorine. When you combine them, they make table salt, this stuff that you put on French fries and things like that. However, if you took those two elements apart, you can see what they'd make. Uh, Sodium being a metal, chlorine being a gas, a poisonous gas. However, when they're combined, the chemical properties of them change. All right, that's because of the combination and the ratio that these things are held together gives them those properties. Another example we'll get. Well, we'll talk about a bunch of examples, but another example is water, H2O. Right, I have two hydrogens and one oxygen. Those are both gases, but when I put them together, they end up forming water. Okay, so all has to do with how they're combined and the ratio with which they are combined. They're always combined in the same proportions, and that's represented by a chemical formula that shows the amount of atoms of each element are in there. Um, So back to this again: water, H2O. Why is this important? This is the chemical formula for water. This chemical formula tells me that in water there's 2 hydrogens for every 1 oxygen. So it tells me the number of atoms, and it tells me the ratio between those atoms that form the compound. Fe2O2, 2 irons combined with 2 oxygens creates rust. And if that ratio changes, well, the compound changes. So these are pure substances. If I put a number in front of the chemical formula, that just tells me how many of that whole substance I have. So 2H2O tells me I have 2 water molecules. 2Fe2O2 tells me I have 2 iron molecules or 2 iron compounds. We then get into molecules. A molecule is still a pure substance. It says it keeps all the physical and chemical properties of that substance, and it can be made of the different or the same element. So I have water molecules, H2O, oxygen molecules, O2. Now, this is an interesting rule. Um, it's true most of the time, but molecules are a little different than compounds at certain points. So it says not all molecules are compounds. Um, so when atoms are combining are the same element, it is not a compound. So water, H2O, we call it a water molecule, and it is. Um, However, water is a compound because it's hydrogen and oxygen combined together. Oxygen, or O2, is a molecule because it's 2 of the same thing. So we got a little picture here to represent it. These things on the left are atoms. I combine atoms to make molecules. So you see here in the middle, I may have 2 of the same one or 3 of the same one. These would be molecules. If I combine them and it's 2 or 3 or 4 different atoms combined together, or elements, I form a compound. And we will stop this video there.